Okay, in this question, we have a nuclear reaction that powers the sun, and it involves a fission, so coming together of 4 protons. So I have 1, 2, 3, 4, which is going to turn into a helium. So I can actually do it like proton plus proton plus proton plus proton, and it turns into a helium atom. And we're given the masses. What we're looking for is that we want to try to figure out how much energy is being released on the other side. And in order to do this, we have to actually understand what kind of energies are involved here. So if I were to write this a little bit simpler in terms of energy, I could write that we know that the total energy is the rest energy of something plus the kinetic energy of the same thing. And the rest energy pretty much means the energy that is the nuclear energy that's inside a resting particle. And that's just the mass of the particle times c squared, and kinetic energy is the mass c squared times gamma minus 1, and this is equal to the total energy of a high speed particle. Now, in this process, none of these things are speeding, so they're not really moving, so we don't really deal with kinetic energy in this case. We only deal with rest energies. Now, if you're actually going to look at and write an equation basically due to conservation of energy, we know that the rest energy of these 4 protons, which are all equal, is the mass of the proton times the speed of light to the power of 2. If I multiply that by 4, it should equal to mass of the helium times c to the power of 2, so to the rest energy of the helium. Now, all we need to do is to add the energy that's being released, and that's pretty much what we're looking to find in this case. I can rearrange this equation for the energy we're looking for equals the 4 times mp c squared minus mass of the helium c squared. Now I can of course take out the c squared as a common factor, so I'm only left with 4 times mass of the proton minus the mass of the helium. And then, so what I'm going to do is that I'm just going to plug in the numbers and solve for the total energy. So I will put in 2.998 times 10 to the power of 8 to the power of 2, 4 times mass of the proton, which is 1.673 times 10 to the negative 27. It is given in this case, minus mass of the helium, which is 6.645 times 10 to the power of negative 27 kilogram, bracket closed. And if I punch in the numbers into the calculator, I will get 4.22 times 10 to the power of negative 12 joules. That's how much energy is being released. That's it. That's pretty much it. All we have to do now is to convert it to MeV. And what we can do, I can use the next page. And I know that 1 joule is equal to 6.242 times 10 to the 12 MeV. And I can write a relation for that. So 1 joule is 6.242 times 10 to the 12. If I were to actually write it, 4.22 times 10 to the negative 12 joules. And I'm looking for what it is in MeV. So what it is in MeV is pretty much this times that. So I can put that into my calculator. So I get 4.22 times 10 to the power of negative 12 times 6.242 times 10 to the power of 12. I would get 26.3 MeV. So the energy released, we're looking for energy released, and that's what it is in this unit. That's pretty much it. If you have any questions, please comment them down below, and don't forget to like this video. Thank you.